welcome to the Bonsecours podcast. I'm with Stéphane. Can you introduce yourself?
Sure. Hi, I'm Stéphane Graber. I'm the VP of Infrastructure for NorthSec, thinking of what's really related to this particular podcast. I'm also a long-time open source contributor to a whole bunch of projects. I'm the project leader for Linux containers, which includes things like Incus, LXC, CFS, and effectively work on open source infrastructure on the work time and on infrastructure for NorthSec on my spare time.
Yep. Per request by Guillaume, he asked me to do it in English because we already did it in French, this part of the explanation of the infrastructure of NorthSec. I will let you go explain it, how we'll do it, and we'll do some part on Incus too afterward.
Yeah, for sure. So obviously it kind of depends on level of familiarity from the audience about what NorthSec is and kind of what we do. But at the highest
explain
level,
NorthSec because we free in a world that I'm not sure that they're aware of the existence of NorthSec per se.
Mm-hmm. So it's at the highest level. NorthSec is a cybersecurity event that we run every year in Montreal, usually towards the end of May. The event's been going on since 2013, so we've been doing that for over 10 years at this point. It started as just a CTF, so a capture the flag event, which was really meant for like a competition of primarily universities towards the beginning, but then more industry kind of joining in, just competing against each other in a number of cybersecurity challenges. And that's evolved a fair bit over the years. We eventually added a conference aspect to things quite a few years back now, and also professional trainings. So these days it's effectively a week-long event where you usually get like 3 or 4 days of high quality trainings that you can sign up for, followed by 2 days of dual track, usually conference with a whole bunch of speakers and panels and the like, as well as workshops and a bunch of other activities. And then over the weekend, we run the Capture the Flag event, which is basically the largest Capture the Flag event in the world at this point. For on-site specifically, like remote, they're much larger than we do, but on-site, we're probably the only ones running things at this kind of scale. I'm actually trying to remember the sizing of last year. I think we were at around 80 teams, I think, basically filling two rooms in the venue we're usually running. So that's hundreds and hundreds of people participating and some pretty interesting infrastructure to back all of that.
Yes, because you're the biggest on-site CTF in the world, the infrastructure to make that happen will be very complex. We have a lot of moving parts, so I'll let you introduce those.
Yeah, and I mean, it's evolved a lot over the years. We're actually at the point where we've cleaned things up enough that even though it's very different from what another CTF might do, we run the entire infrastructure kind of year long, and during the CTF with just 3 or 4 people at this point. So it doesn't need a huge team to run this. We've actually streamlined things quite a lot. And to give you an idea, like NorthSec has a pretty large organization team. We've got right around 90 year-long staff on NorthSec for NorthSec. So like it's all volunteers. Like none of us are paid or anything, but we've got around 90 volunteers that put the events together. Anything from people designing the challenges, folks who are in charge of the CFP and running the conference side of things, those who are running our community rooms, so effectively kind of DEF CON villages type stuff. Everyone, like also marketing, handling sponsors, all that kind of stuff. So we're a pretty large team. And on the infrastructure side, we have kind of 3 different things we need to deal with. We've got the year-long infrastructure and kind of staff management things. So we've got what would normally qualify as basically a mid-sized company at this point, but we're all volunteers, and we don't have HR. We don't have people who are really around to manage that stuff. So we've automated basically everything you can. So all of the account management, account access, all that stuff is automated, because we also have a lot of stuff moving around from year to year, whether they change their role in the organization, whether they leave. We actually had a number of challenge designers who would be on a rotation effectively, where like some of them every year, every 2 years would leave the organization to come back as participants for a year because they actually like participating, and then we join back as an organizer again the year after. So we've got a lot of movement that we had to automate and manage. So that's one of the things we do. We also obviously need to run things like our website and a bunch of other year-long infrastructure. We also run a project called Ring Zero CTF, which is an online capture the flag kind of setup where you can go and actually try a whole bunch of challenges. Some of those come from NorthSec, just on your own online. There's a Discord community, and that's effectively running year long on the same infrastructure that we use for NorthSec. Then we've got kind of the support infrastructure for the rest of the event when we run the event on site. So that's basic networking, Wi-Fi, all that kind of stuff for the week at the venue.
And the venue is very unusual to have those kind of event, because it's not, as I remember, not easy to plan some networking stuff, Wi-Fi stuff, and to manage it.
Yeah, so the venue, so we always go to Marché, Bonsecours. Artists we have been for the past almost decade now. 2 of our initial editions were at a university instead. But yeah, Marché, Bonsecours is kind of known as a good venue for large gatherings, weddings, that kind of stuff. It's not your normal convention center with cookie cutter big rooms. So it is interesting. Like we're used to it by now. We know where we can install equipment. We've also done significant work in the venue itself over the years. Like we effectively installed fiber to all of the rooms. So we've got about 20 gigabit of bandwidth to each of the room. And then we can go from there and then run shorter network runs for all of the Wi-Fi's and stuff. But when we set up the venue, the other thing we need to think about is what is it going to be used for? Like the setup of a room varies a lot between what you do for a conference and what you do for the CTF. For a conference, and we're going to put 5, 6 high capacity access points, and that will handle all of the Wi-Fi needs for that room, and we're fine. Because a lot of people don't even bother to go on the Wi-Fi, and those who do tend to, at most, check social media and access a few things here and there, but that's not going to be high throughput. CTF is quite different, because over there we certainly have much higher density. Like we've got like tables of 8 people, each bringing at least one device, but usually having both their phone and laptop on the Wi-Fi. And on their laptop, they're not just accessing social media, they're downloading virtual machine images that are tens of gigabytes large. So that is pretty different. We usually end up having effectively 1 access point per 2 teams. I think that's about the density we usually have in those rooms, which if you were looking at any kind of normal Wi-Fi placement for a venue, people would just think you're completely mad to do that. Because like you literally see access points like one next to each other, and it's a bit of a challenge to not have interference and all that kind of stuff. Like you effectively need to run at very, very low signal strength, small channel width to still give the performance we want. Effectively, our goal is to be able to do 100 megabits symmetric per client, basically at any time. And we've usually been able to provide that on the Wi-Fi side of things. So yeah, we effectively set up the venue, we put all the Wi-Fi in place, all the switches, all that stuff. The main servers and everything don't move. They're year long at the data center in Montreal. And like one of my hobbies on the side, like separately from NorthSec, is that I'm also my own ISP. So I do have membership on the local internet exchange. I've got my own address space. I've got multiple transit deals and that kind of stuff in the data center. So what we do is we make sure that whatever venue we use is with one of the ISPs that has direct connection to the Montreal Internet Exchange. which then gives us a point-to-point link effectively between the venue and our equipment in the data center. So typically we've got 10 gigabit symmetric fiber with basically no latency going straight line to our servers in the data center. And that means we don't have, we are in full control of the network, because that's pretty important for the CTF.
Yes, that's changed by year, because when you start, the data center was on site and moved progressive to a real data center over time.
Yeah, exactly. So that's been changing over the years. Like although at the beginning of NorthSec, we had all donated hardware, like both servers and switches, in the only investment we did at the beginning of NorthSec was buy a physical rack, like a half rack on wheels. That was basically the only hardware we had purchased. Everything else were like donations from universities, telcos, a bunch of other folks. And we were running on donated hardware and basically praying that nothing would break during the event, because if a server decides to go dead in halfway through the event, there's literally nothing we could do. Like no amount of quick eBay buy spare parts and stuff would really save you. So that's been working well enough. And we were usually, effectively storing those servers in some warehouse or something, would bring them up a bit before the event, make sure everything works. And then we would bring them with a truck in the venue itself and plug them there. So that's what we had all the way at the beginning of NorthSec. Then things evolved a bit over the years, where we replaced some of that equipment with newer donated equipment, then eventually replacing that with some servers and stuff of our own that we purchase ourselves, and just kind of modernizing to what we have right now, where effectively all of the gear fully belongs to us. It's all normal modern server hardware. There's nothing unusual. Like it's 6 identical dual AMD EPYC servers, so 64 cores per machine, 128 threads, a couple of terabytes of RAM per server. All of the storage is enterprise grade NVMe, and we're on, I think, 40 gigabits of network per server in there. So we've effectively over the years upgraded to something that is basically normal enterprise grade kit that we own. And to justify that, part of it was, well, we need this thing to be kind of used all year long. So that's where things like Ring Zero and those guys make a lot of sense, because now those servers don't just sit idle most of the year. And we used to actually bring that equipment even after we switched to mostly modern servers, up until I think right around the pandemic, basically. So the equipment was usually in my basement in Montreal year long. And then we would just load it into a truck, bring it to the venue for NorthSec itself, and then bring it back after. That was working well enough, and it was good, obviously, for bandwidth needs and those kind of things, because we had the servers on site. But as soon as we started doing Ring Zero, it was a bit awkward, because now suddenly we had to take down Ring Zero for the days we were moving everything, and then Ring Zero would technically run from the NorthSec venue at the same time as everything else, which was a bit weird. Not to mention having to de-rack all the servers, drag them all back, rewire everything, test everything every time. Even though we're getting pretty good at it, that was still taking easily 4 or 5 hours to get that stuff working. So we eventually kind of stopped doing that. I think during the pandemic in 2021, I think, is when I signed a deal to have colocation space for my own stuff at the data center. And then I effectively expanded that to have enough space to also put the NorthSec equipment there. And then we just moved it all in data center, and we've never moved it back, because it's much simpler this way. Everything stays where it is. And when we show up at the venue, we just need to show up with our switching gears, Wi-Fi, and a very basic router that just sets up the tunnel back to the data center, make sure everything is good, and we're good to go. So these days, usually about 15 minutes after I arrive at the venue, we've got network working. Like, as in we've replugged the fibers, we've taken over the main networking in the building, and we can already start plugging Wi-Fi access points if we want to. That's compared to, it was basically a day before for us to get that working. So that's gotten a lot better, and it's a lot simpler for us now.
Yeah, and by having no latency between the site and the data center is a great advantage in this case.
Yeah, and it gives us other advantages. Like before that, since we weren't using myself as the ISP, we were using whatever the venue had, which was coming with some interesting side effects. Like pretty often we would show up and the network was not functional. But because we always set up over the weekend, there was like the ISP had no staff or anything, or we had to like call a bunch of people to try and find someone who could come and fix their config because they messed something up here and there. Now we don't really have that problem. We can fix just about everything ourselves, which makes it a lot simpler. And the other thing is because we're running on our own address space, it gives us a lot more control. Like if someone starts attacking a public website or any of that kind of stuff, we are our own abuse contact. So it avoids the whole issue of it going to an ISP who freaks out and cuts you off like halfway through the event. And there's nothing you can do until Monday because they don't have staff to respond to you till Monday. So that makes it quite a bit easier. And it just gives us more control. And it's one of those things where, like, funnily enough, like being in charge of more things ourselves actually cut down in the amount of time we need to spend dealing with it. So it's actually worked out pretty well. Where we've gotten extremely efficient now. Where basically in one day we can rewire the entire place, put all the Wi-Fi in place, test everything, and be basically good to go.
Yeah, you earlier have the cookbook to do the stuff very efficiently in that way.
Yep. And I guess the other part of the infrastructure, which is kind of unusual, and maybe some people are wondering at this point, what the hell are we doing? Because I mentioned we've got 6 servers, 64 cores per server. Like it's pretty big infra, and a lot of CTFs are quite a bit simpler than that. Like a lot of CTFs, when you go participate in them online, the most common pattern is like a Jeopardy type board. You could just get like a table. You've got challenges like in 5 categories for like 100, 200, 300, 400, 500 points. You click on the thing, it gets you some instructions. Most of the times you just like download a binary or VM image or something, you deal with it locally, and then you get the flag, you submit it, you get the points. For some of them, you have services you need to attack, and in most of those CTS, when you do have things you need to attack, everyone's attacking the same thing, which might work if your challenges are very well designed, but also quite often does not work so well because those attacking are pretty darn smart. And back when a bunch of the NorthSec organizers were participants in those kind of CTFs, we were always looking at doing the challenge, getting the points, and then immediately spending the extra 10 minutes to find a way to prevent anyone else from doing it again. Like if there's a way to subtly break the service so that others can't get the points anymore, well, that helps you out. And that means sometimes like denial of service attacks. Sometimes it means just, okay, you can corrupt the memory, you can corrupt the file on disk, or you can corrupt the flag itself to a different value. And eventually the organizers will figure it out and fix it, but maybe they won't, or they will, but then people will have skipped that challenge and gone to do something else. So that's something we always wanted to really avoid with NorthSec. Like we don't want one team being able to impact another. And that's why our infra is so large, is because when we've got 80 teams participating, we've got 80 times the exact same infrastructure deployed. So we effectively, like each team connects to the infra through a VPN. And from that point on, they're on their own team subnet. We use that to know who they are when they access things like the central forum that's got a lot of the guidelines and challenges on, when they access the scoring system, all that kind of stuff. So we can easily know who they are, what team they are at any point. And then when they access the challenges, everyone accesses the same IP addresses, but it's going through a per team routing table, and they actually access their own copy of that infrastructure. So even though they all attack the exact same IP addresses, the exact same services, they're actually dealing with their own system. And doing that,
their own stuff. Yeah. And by doing so, you have some complication on the back end side to make that happen.
Oh yeah. Yeah, so obviously we need to make sure, it starts from the challenge designers on our side. Like when they prepare a challenge, they need to be aware of how that works. Some challenges are just static files or the like, so those, no problem. It's on a shared web server, it's fine. But anything that requires infrastructure, whether it's like a full VM or a container or something, then they need to effectively be aware that like this is going to get copied 80 times. We're going to have a lot of those things running at the same time. So any small bug you have that only shows up 1% of the time, well, guess what? It's going to show up now. So that means, yeah, we need to have some pretty good ways of testing all the challenges, testing and monitoring things. Because unlike a normal CTF where you just need to check one service, in our case, you need to check 80 or 100 or whatever number of teams we have. And one team like complaining, oh, my challenge is not working, doesn't mean it's not working for the rest of them. And you need to really keep an eye on things and having good ways of keeping track of the uptime of all the challenges, having good ways to repair them, and having tooling to go and repair them all. Because during the development stage, they prepare their challenges on what we call the original copy, so they can do whatever they want on there. And then we'll take that and copy it 80 times or something on the usually Wednesday or Thursday of the NorthSec week, and the CTF starts on Friday. The problem is if they messed up and there's like a bug or something needs fixing, we can't just go and clone the whole thing again, because that would lose everyone's state in all of the other challenges. So we've got tooling to effectively apply, whether it's just like a replacement of a file or running some commands or those kind of actions for a specific challenge across all 80 teams. So we've got some pretty good tooling to do that by now, which also goes and effectively creates snapshots before and after. So if the fix we're pushing causes more damage than it fixes, then we can go and revert things. So we've got a lot of options there to make it pretty easy to reset something. We also use those snapshots as effectively a way to reset any team's damage. Like occasionally, teams don't. I mean, the most funny thing we keep seeing is that teams don't realize that they are in their own environment, and they get access to a shell server, and one of the first things they will do is like, oh, wipe the disk. Okay, cool. You just made your own life a lot harder, but you didn't really do anything to anyone else. So then they kind of have to plead with us as to whether we will be nice and go and fix it or not. Occasionally we go with not, because we're like, look, everything is done within like a scenario. Like we're pretending that you are, employees of a company, or you're working on, they've been like dealing with being part of a bakery in the past, like a whole bunch of wacky scenarios over the years. But there is a scenario, they have a role to play. And if the scenario is that they are like a pen testing crew and they effectively just wiped one of their customer servers, usually the customer doesn't just go and fix it for them. So like in some of those cases, are like, well, I guess you're going to have to find a way around that, because why would you do this? Like it just make your life a lot harder.
Yeah. You shoot yourself in the foot. But doing fix in live production is somewhat hardcore, because it's like repairing an airplane in flight. So it's very hard. It's not usual to do those kind of stuff.
Yeah, exactly. And there's like no way for us to know what they might have done either. That's always the hard thing when we deploy one of those patches, is that, okay, the patch has been tested on our own copy, but our own copy is clean. We haven't been like attacking it in like 50 different ways. We've not run every single automated tool that they could find on the internet against it, or any of that kind of stuff. So that's where it can be tricky. Occasionally we know that like when we patch a team, we actually make it worse, but that's where we have the monitoring. Like we effectively have a Grafana dashboard on the infrastructure side that shows us not only the core infra stuff, so like all of the traffic on all of the different Wi-Fi access points to make sure everything is well balanced, the traffic on all of the switches and VPNs and everything to make sure everything is fine. We also keep track of the traffic on the DNS servers and on the scoring system. That's mostly to find people abusing the infrastructure. Things like doing brute force of DNS records, brute force of the scoring system, so we can pick those up very quickly and block them. But we also get all the metrics and the challenges. So we know we effectively have an ever updating to-do list of stuff that looks like it's unavailable, or like weird error in this file that we don't expect. We need to go look at it. The kernel in one of the VM is throwing some errors that it's not supposed to, or only of the network ports not responding, HTTP servers not returning the normal response, all that kind of stuff. So we effectively have all of those checks run about every 30 seconds. So we effectively test everything every about 30 seconds. And we've got that list of what's impacted. And then because just keeping track of that is basically impossible. We get way too many things breaking all the time. We've actually automated the repair process as well. So for a lot of those challenges, we will effectively, the first time we see them showing up as broken for a given team, we just issue a restart on it. Like we just restart the container and see if that fixes things. Then if it doesn't, often we will go and do it by hand, effectively doing a revert on the latest known good snapshot and then move on. But if it's a challenge that we see people keep breaking, as in they keep doing some action that breaks the service and needs a reset, then we can also automate that, effectively saying for this service, we know something is going on that's wrong. If you see it go down, don't even try to restart it, just restore the previous snapshot and bring it back up. So that's something we automated mostly last year, because that was the first time we were on 2 different floors and added another 20-something teams, I think, compared to usual. And we were also short-staffed a bit on the infra side, since 2 of our team members were traveling to Europe at the time. We were effectively running everything. Who did we have? I think we had effectively 2 people for the entire thing. So we were definitely running scripts to keep up with everything. And that worked pretty well. Like at the end of the day, we usually were noticing things being down before the participants did. So even before they would open like an internal ticket saying like, hey, my challenge is not working, can someone look at it? It would already be back. And that's kind of how we like things to be. So.
It's pretty rare that on my experience that we have this level of observability on infrastructure that just solve the problem before the clients see it. But it's pretty neat.
Yeah, I mean, for us, it's just because that's the only way we can deal with this kind of scale at this point. And yeah, like in many other cases, it's not really practical to try and do it to that extent. But like for us, what we effectively ended up doing last year is just before we started cloning that stuff for the different teams, we literally looked at every single container, every single thing that was running, looking at all the processes that are not stock processes, and look at all of the ports that were open in every single one of those things, and basically putting all of that in the monitoring, being like, that's how it's supposed to be. If we see any of those ports go away or any of those processes go away, we'd like to know. And then we can trim the list down the line. Like some of it, like we code false positives, like processes that just like show up and disappear, or ports that open and close over time. That's fine. We'll see them. We'll remove them. But the way we've done it last year, we effectively ran the entire NorthSec infrastructure as like a dry run on Monday, Tuesday, Wednesday, I think, of the event when the CTF starts on Friday. Just running full tilt, all 80 teams running to see what services are going to break over time. So effectively, start with everything being in a good state, and then see, okay, 3 days later, what broke? So we can already get prepared for what's going to happen over the weekend, especially as people put more load on it.
Yes, and that's one part of the infrastructure. The other part is all the hosting you use, because in this case, in particular case, you're part of the team that work on the containerizing side of what you're using for NorthSec.
Yeah, exactly. So that's something else that really evolved over time. Like when we started NorthSec, we were doing pretty manual container stuff. So we're using LXC directly. I was already the project leader of LXC at the time, so it was already like a case of using our own tool. But we were on LXC for a while. And when I started developing LXD at Canonical, and we moved over to LXD to have like a more API-driven way of managing all of NorthSec, which was really useful because it was providing a very useful feedback loop. Like NorthSec was effectively pushing things to a level that no customer would realistically be doing. Like at the time, we were still on less powerful servers with a lot less hardware, and we were effectively running, I think, something around 12,000 containers per physical machine, which was hitting all kinds of weird bugs and issues that we then fixed in LXD, which then ended up being very beneficial for customers later on when they started hitting those kind of scales. But also found a whole bunch of really hard to hit kernel bugs in Linux, firmware bugs in Cisco switches, like a whole bunch of weirdness. Mostly because we're an environment that runs basically exclusively on IPv6. That's one of the tricks we use so that we can very easily give large subnets for the different tracks and challenges without needing to be extremely careful about what address space we use. So we're all IPv6. And because we do that thing where every team has their own copy of it, we actually have the exact same MAC address used 80 times. We've got the exact same IPv6 address used 80 times. And they're all isolated in their own like either virtual networks or physical VLANs. But we've noticed that a lot of both logical and physical network equipment really didn't like that at all, because that's not normal. And we just hit a bunch of issues over the years. The good thing is that these days, it's effectively all done. Like we've not hit any such network level or kernel level bugs in 2023 or 2024. I think the last time we had some pretty major kernel issues or weird bugs showing up during the event was 2022. So it seems like we've mostly over the years kind of nailed all of the weirdness and gotten all of those things fixed for everyone, whether it's in Linux or in other pieces of software. But yeah, we effectively switched from LXC to LXD initially. Then LXD at the time was only doing containers. So we were doing libvirt for virtual machines. And we also didn't have enough hardware to run VMs. So the VMs were actually at that point offsite at OVH with some weird VPN stuff in place, which was working well enough. But there were machines we only had access to for like 1 or 2 weeks during the year. So that really limited the amount of time we could spend to make it work really well. And we also hit a bunch of weird issues and stuff like that. Then LXD added virtual machine support, which let us effectively have a single control plane to manage all of that stuff. So that was pretty convenient. But there were some security concerns still with the way of running access control and isolation and stuff. So we were technically running 3 different LXD clusters, one for the CTF itself, one for Ring 0, and one for the core infrastructure, which was adding a lot of complexity. That was definitely making it hard to maintain and hard to manage. So when we switched over to Incus after I left Canonical in 2023, that's when we also cleaned things up, because Incus is actively used by some public cloud providers and the like. So it is designed to have pretty good access control that you can really have multiple tenants and stuff dealing with it safely. So that's what we did. We effectively collapsed everything into a single Incus cluster now that runs directly on the 6 physical machines we have. And that runs everything effectively from our public website, the CFP sites, all of that kind of year-long infra, to backend services like the Discord bots and all that kind of stuff, to all of the VPN gateways we use for the participants to connect to the infrastructure, to the shared part of the NorthSec infrastructure, so the main web servers for the challenges, the forum we use as the entry point, the scoring system, that kind of stuff, and some of the observability metric gathering services there, and then all the stuff that's per team that we actually end up cloning. One nice property of how we've done it is that we've actually managed to reshuffle and re-import the data from previous years. So we technically have in that cluster available at any time, I think everything since 2014. So that's proved itself to be useful occasionally. It's pretty rare, but sometimes we get a bit stressed out by people being too good at completing all the challenges. For the longest time, we basically never had anyone hit more than 50% of all the challenges, which is kind of how we like it, because otherwise people start running out of content that they're familiar with, and they really struggle with the rest. But I think it was during the pandemic where one of the year where we had a team that was getting like 70-80% completion. Like, okay, that's getting dangerous. Like we don't really want that to keep going. So what we did is we actually looked through the scoring system for previous, like through our backups and our data in previous years to see what challenges were never really attempted, what challenges were like never used, that were therefore safe for us to live copy into an ongoing NorthSec edition to get extra points in there. So we did that. We effectively copied an entire track. I think it was like 8 containers, probably worth like 20 or 30 flags. We got 20 or 30 points, and we copied that. As everyone was participating, we were effectively copying that stuff across. So it's pretty neat that we can do that. We also have, like, we were mentioning earlier that the worst thing that could happen is like hardware dying during those 3 days, because it's the middle of a weekend and it's pretty tricky to fix anything. In general, what we do is that we plan with spare capacity. So we could lose one of the 6 servers and be fine. Not a preference, but we could at least lose, we could deal with it being gone for a little while and send someone to the data center and see what we can recover. So we've got that spare capacity, and so far we've never needed it. So we actually tend to use it for something else, which is my team, whenever we get a bit of spare time during NorthSec, we usually use the opportunity to go and do rolling updates of everything, deploy next year, and do some other stuff like that. So the infrastructure is redundant enough, like we're software-defined network, software-defined storage, everything is HA, that we were literally doing rolling updates from like one version of Ubuntu to the next LTS on the core services during the event. Because that was when we had the most spare time to do it. And yeah, no impact whatsoever, because it's designed that basically all the services are running 3 different copies. If we take one down, we still have 2. It's fine. So,
well, yeah. But at the same time, we don't suggest to do that in real production environment.
No, exactly.
But that's quite crazy. It's risky to update in a lifetime production. But at the same time, you have so much confidence in your infrastructure that you're able to do it anyway.
Well, and what happens is that we're all volunteers, so we only have so much time the rest of the year, whereas the NorthSec week, we are all on-site dedicated to the event. So if I'm going to be on-site between 8 a.m. and 3 a.m. and everything is working smoothly and all of our systems just like repair themselves and we don't really have anything to do, that's the most time we actually have to dedicate on working on the infrastructure during the entire year. So that's why we end up being like, okay, well, might as well and start dealing with our backlog of tasks and improvements as we're running the event.
On your back. And you talk about the control plane from LXC, LXD. In case the control plane is probably the most vulnerable part, as most prize for attacker to go there. How you protect it?
Yeah, so I mean, basically the normal way, in that there's no. So there are a few knobs that we can use to decide whether we want to expose any kind of communication channel between the guest and the host. And in the case of NorthSec, the answer is no. We disable that completely. So there is no way from within a container or from within a VM at NorthSec to communicate with the host. And obviously on the network side, they're completely isolated as well. So it's completely separate networks for all of the physical stuff than it is for all of the challenges. So there's no way for any of them to route through anything they could attack for the control plane. So yeah, that keeps things pretty nicely isolated there. And that's the same kind of knobs that someone would use if they're running like a public cloud based on Incast. Like you generally don't want that kind of attack surface. If you can completely disconnect the guest from the host as far as what it can interact with, then there's no real risk there.
You reduce the attack plane. you didn't talk about it yet. For 1 year of the NorthSec, you did an internet simulation.
Oh yeah,
and you test the containers container to the maximum to see how it's work. Can you talk
yeah.
about
So we
it?
used that a number of years actually. I think we used it like 2 or 3 years in a row. It's every year, like I kind of talk to our challenge designers and talk to them about what tools they can use. So I did that presentation again this year. I don't know if there's going to be any use for this tool this year or not, but yeah, we effectively wrote a tool that lets you simulate the internet effectively per team. So what it does is we can define a number of ISPs, a number of internet exchanges or peering points around the planet with GPS coordinates. And then we've got a tool that takes that data and generates a whole bunch of containers to act as virtual routers. And it will then create links between those and apply realistic latency on those links. And that effectively makes it possible to quickly generate, like per team, maybe 300 to 500 containers that create that fake internet. And then you can attach your challenges to any of those locations. So 1 year we were the Kingdom of Rao, which was effectively modeled after North Korea. So all of the services were running in North Korea as far as the fake internet was concerned. And we were running it with like pretty high latency, and we were pretending to be on a dodgy Wi-Fi link, I think, between the Kingdom of Rao and their closest peer. So that meant also injecting packet loss and that kind of stuff on the link. So yeah, we've got that capability to do it. When we do it, that obviously immediately inflates the number of containers quite a lot. I think a normal year, we usually have maybe 50, 60-ish containers per team. When you do that, then you add another 300 to 500. But they're very, very lightweight. They effectively just run like 3 or 4 processes each just for the router. But that does put a lot more strain on the Linux kernel, because this is simulating the real internet. So each of those routers gets what would normally be the global routing table. And on the real internet, the global routing table, I've not actually looked at it the past few days, but I think IPv4 is, what is it, like 900,000 entries or something. And IPv6 is like 150,000, something like that. Anyways, there's a lot of routing entries, and because each of those containers act as a full router, each of them had that many routing table entries. So it really quickly adds up. And some of the years we were running that, we were not running it. So these days, what we do is we've got one big VM per team that then runs nested containers in there. That gives us a bit more control on blast radius. If the Linux kernel decides to go to crap, then it only impacts one team, not everyone. But back when we used that, we didn't. So we had probably like 20 teams running on one server, each of the 20 of whom were running 300 plus containers that each has hundreds of thousands of routing table entries. And that's when we hit some issues, like severe performance issues on Linux, because nobody ever ran to that kind of scale. Like the largest scale of number of routing table entry that anyone realistically can think of on Linux would be the full global table from the internet. But in our case, we were doing that hundreds of times. So that was pretty interesting. But yeah, the tooling still exists. It's not been used recently. I know it's been used by some companies as a way to like test their CDN and test their infrastructure to really look at what would be the impact if this country goes down? What would be the impact if we get into an argument with this particular tier 1 company and they stop routing our traffic? What's the impact if this server over there dies? Like it really lets you test a mostly realistic internet. And I gave a couple of talks on that at various conferences over the years, where pretty often what I would do as a demo is literally pick whatever the physical venue of the conference is and go on the fake internet and look at on the fake internet what the latency and the route would be from there to some country on the other side of the planet. And then do the same thing from the actual conference venue and compare. And we're usually within like 2 or 3 hops difference. So like the number of routers is pretty close. And latency wise, we're usually between like around 10 milliseconds-ish of reality. So the simulation is pretty good and could be made better by just adding more entries into a spreadsheet, basically. Because the more routers you define and the more locations you define, then the more accurate it gets. So yeah, it's a pretty cool tool. I hope we'll get to use it again at some point in the future.
Yeah, it's pretty cool. We cover a lot of ground. Is there anything that we haven't covered that you like to discuss?
Let me think. I think we covered like all of what NorthSec is, all of the on-site stuff, most of what our infrastructure kind of looks like. Then maybe one thing to mention there is like, yeah, NorthSec is just 1 week a year, and we have Ring Zero and our websites and stuff running the rest of the year. But we also get going pretty early on with adding more, developing the challenges for the next year and putting infrastructure in place for the next year. At this point, I think people are having meeting every 2 weeks or so to design challenges and prepare them and start rolling them out. And we also improve the infrastructure kind of every year. One of the things we are working on this year that's going to make, I think, our lives quite a bit easier in the future is, up until now, deploying a challenge for a challenge designer meant directly accessing our infrastructure, creating whatever containers they wanted, and then in that container deploy their software. And we had kind of templates for most of the Linux distros, and we had some guides for how to deal with Windows and those kind of things. There were a few things that people kept asking for that we didn't have a good answer for. One of which was, hey, there are all of those Docker container images around. Can we just use those? And the answer was no, because at the time, our containers are what we call system containers. So they were running a full Linux distro. But now that has changed. Earlier this year, I added support for OCI containers in Incus. So now we have the choice to either run a full distro system container or consume effectively a Docker image and run it directly on Incus. So that will be a nice tool for change designers this year, because they won't have to necessarily deal so much with how to configure Postgres, MySQL, or whatever else. They can use pre-made images for a bunch of those things. The other thing that we're pushing for, and that's going to be different this year, is up until now, they would manually go and create their containers and deploy their challenges in there. That was fine, but then it was always getting a bit tricky on how to manage updates on that. Do we just apply all the package updates, or are they running old stuff on purpose? And it was pretty hard to tell, because with a bunch of the challenges, they want to run a old buggy version of OpenSSL or Apache or something. That's the whole point. And if you go and update everything and apply all the security updates right before the event, you just broke the challenge. So that's always been a bit of a problem for us to know just how much to go and patch and how much to just leave alone. So this year, we're moving to a workflow where everything is deployed through Terraform and Ansible instead. So all of the challenges are effectively defined in our development Git repo. That defines the virtual networks they need, all instances they need, whether they're containers or whether they're system containers or application containers, the DNS records they need, all that kind of stuff. And then the deployment itself can be done through Ansible. So we don't really need to think about applying security updates and stuff. We can effectively just blow everything away a week before the event, redeploy everything clean at that stage. And any package that's old will have been purposefully installed old, so we'll know not to touch it. And that's going to make our life quite a bit easier. And it will also make all of those challenges so much easier to port to a platform like Ring Zero afterwards. Because right now, Ring Zero mostly operates on a shared infrastructure type design, because they can't afford to copy the whole thing for every participant. And they do have a bit now of what they call spawn-to-pawn, which is a service where you do get a temporary instance created just for you on a network with WireGuard. And the idea is to use that service more and effectively pull the challenge definitions from NorthSec, so the actual Terraform and Ansible, and just include that directly into the Ring Zero tooling, so that they can be deployed potentially just a few days after NorthSec. You can go and try out the NorthSec challenges on the Ring Zero platform without needing to spend weeks effectively reverse engineering how a challenge was put together so that you can then automate it on the Ring Zero platform. So that will be pretty nice. That's again, more automation that we're putting in place, because we only have so so many staff around that we need to automate as much as we can. So we can run that stuff year long and do a good job at it without it consuming all of our spare time.
That's pretty cool that you at a level, an enterprise grade level. So that's very nice for a non-profit organization to be able to do so. Thank you very much for the sharing, because I think many people are eager to know how you work. I'm looking forward for the next NorthSec. At the time of the recording, we still in 2024. The 2025 NorthSec is about to happen in next May, I think. And I will invite you back to discuss those parts you just talk about, to what you change, what you evolve, and what you are about. Thank you.
Yeah, for sure. And we've got so NorthSec is 10 to 18th of May 2025, and we've got all of the tickets and stuff are all up for sale now. They were announced, I think, over the past 2 weeks. So the trainings, conference, and CTF tickets are all available on our site, and currently most of them are on early bird still. So for anyone who wants to come check it out in person, then now is a good time to go and register.
Yes, thank you.